Hi, in this video, I'm going to show you how to construct Amazon Athena Federated query. So here we will have two data source. One is Amazon RDS, which is actually hosting SQL data store, and the other one is Amazon S3 bucket, which is actually containing raw data in the form of a CSV file. Now, say that there is a business case where you want to run a collective query on the whole data set. Here the data set from Amazon S3 bucket plus Amazon RDS, right? So you want to run a query collectively on these data. So how to do that? The solution is called Amazon Athena Federated query, right? So here we're going to use Amazon Athena, the service where we can collectively build a query such a way that can be run across these two types of data, right? So here we will see how to enable Amazon Athena to actually extract the data from Amazon S3 bucket, right, with using the AWS Data Catalog. So here we also going to use AWS Glue for data extraction and creating data in the AWS Data Catalog. And we also see how we can build the connection to the Amazon RDS so that we can also extract the data from Amazon RDS with using the connections here. And then finally we will see that how we can finally run and federated SQL query so that we get the collectively required insights from these two data, right? So there are lots of business use cases where enterprise has to run a collective query on the different types of data, right? So data that is stored in Amazon S3 bucket is completely different than the data that is stored in Amazon RDS, which is actually SQL based storage, right? So so this is the unique situation where the required query that you want to run on this kind of data maybe give you a very valuable output, right? So and this is the the lab scenario which gonna help you towards that aim, right? So with that being said, I'm gonna take you to my AWS account here. So let me take you to my AWS account here. So this is my AWS account. Currently I'm in Oregon region. If I go to the RDS, so in this RDS what I did is I have created an example PostgreSQL RDS database. And if I open this PostgreSQL RDS database, so this is actually created in my VPC. You see that I have the VPC. This one, in that one we have a subnets, and we have a S3. We have the security group. So in this security group, I have opened all the inbound rules, right? So which I'm going to show you right away like this. So if I open this VPC in the another tab, so what I'm going to show here is, so what is that configurations that is exist in Amazon RDS, right? So if I go to the VPC here, so we have a VPC, we have a subnets, and to this VPC I have an internet gateway, right? And then I have the security group which I showed you, and that security group actually allows all the access because this is a demo. So for that case, I have allowed all the access. If you see here, and if I click on edit inbound, so these are all the rules I have allowed for your information. Okay, so with that I'm going to close this VPC configurations on the RDS. Now, so this is an example Amazon RDS, which is PostgreSQL type of engine. So in this one, I have for now I have enabled the public access, in the sense somebody from the public can access this database. Okay, the main aim of this video is to help you to build how to build the federated query on the Athena, right? So here this is our data set. So in this one I have if I go to the configurations, so here I have this is my username, password. I have created an example database called test, which I'm going to show you here. So what we do is I'm going to connect to this Amazon RDS from my PZ admin. Okay, so I have a client called PZ admin 4, which is actually PostgreSQL admin. So in this one, if I log in, you see that I have already logged in. In this one, I have a database called test. In that one, we are using the public schema. And within the public schema, I know I have created an example, I'm example table called employee. And if I run this table, in the sense if I query this table, so I have a set of data. So I'm going to refresh the connection because it is the long time that I have not run the query here. So what I'm going to show you here is that, so we have a one type of source of data, that is Amazon RDS, of PostgreSQL type, right? So this here we have a table called employee, and in that employee table we have these many data. Okay, so this is our source 1 data set. Now let's go to the source 2 data set, that is actually an S3 bucket. So if I search the S3 bucket, right, so I need to open this S3 bucket here. So in the S3 bucket, I have another source of data. So let me open this. So in this one, we have a S3 bucket called S3 bucket source side. So in this one, we have test report.csv. So the data set in the test report.csv is something like this. Okay. So now, since this is a demo video, so I have two types of data. One is in the form of CSV, and the other is in the form of a SQL. Now think about, so how do you want to run the the collective query and this data, right? So in that case, it is important for us to bring both the data in a single plane, that is with using the join queries, that is with using the SQL query. Okay, so that can be possible with using Athena. Okay, so with that note, what I do is I'm going to take you to the Amazon Athena. So this is Amazon Athena. Remember that my source of data, that is in the Oregon region. Okay, so I need to go to Amazon Athena of region Oregon only. So I'm in Amazon Oregon region under and also on service Amazon Athena. So here, if you click on query editor, right, so this is where we actually do run the queries on the different data sources. Okay, now we need to build the data source. Okay, if I go back to the diagram, so here Amazon on the Amazon Athena, so we need to build the two types of data sources. One coming from the Amazon RDS, one coming from the S3 bucket, which is actually, so we will see how we can build that here, right? Now, if I go back to the Amazon Athena, click on this one. So here there are data sources. If you click on the data sources, by default, Amazon Athena has a AWS Data Catalog. So AWS Data Catalog is nothing but, that is data that is collected on a AWS Glue. Okay. So for now, what we do is to extract the data from Amazon S3 bucket, we're going to create an example AWS Glue crawlers. Okay, so what I do is I'm going to search the Glue now, and we're going to create a crawler to crawl the data from that S3 bucket. Okay, so first let me go to the Glue crawler. So before we go to the Glue crawler, right? So in the data catalog, what we do is, we're going to use the crawler option. So click on the crawlers, and currently we don't have any crawler. Okay, so remember that I'm still in a Oregon region like my Amazon RDS. So click on crawlers and then give the name of the crawler called like S3 bucket, and description you can keep it default. Click on next, and here data source configurations, click on add data source. Here data source is S3 bucket, network connection not required. So in the S3 path, click on S3 bucket, and then here you're gonna choose this source side. So click on that, and then here put a /. Okay, and then click on add source. Okay, so with this operations, what we did is we have enabled a crawler which can crawl this data source, that is Amazon S3 bucket. Now I'm gonna click on next, and here you need to choose an IAM role. So this is my normal ETL job IAM role. So this is like ETL Lambda access role, which has a admin access and it is trusted by AWS Glue services. Okay, so with that, I'm going to go to the next, click on next. So here, this is something you need to know, right? So basically, if you go to the data catalog, go to the databases, right? So by default, so we will have only one database, that is default database, which you don't want to use. I'm going to create my own database underneath the AWS Data Catalog. So I'm going to click on this add database. And here we're going to create a database called say S3 DB. Yeah, very simple name. So I'm going to create a database name called S3DB. So I'm going to click on this create database. So basically underneath the data catalog, we got a database called S3 database. I'm going to switch back to the another tab, that is where we were actually continuing the crawler configurations. I'm going to refresh it now. So we should be able to see S3 database. Now here table name prefix, in the sense if you'd like to have some prefix, you can give it. So I'm going to give it as a S3 underscore. Rest all options you can keep it default, and frequency let it be on demand. Click on next, and click on review. So once you click on a review, the crawlers will be created. So here you can refresh it, the crawlers should be visible here. Select that and click on a run. So once you click on a run, it's gonna take maybe 30 to 45 seconds to complete the job, right? So once currently it is a running stage, Once the status changes to the stopped state, we're going to expect a table being created underneath the database called called S3 bucket. So S3DB. So if you go to the S3DB, we should be able to see some data getting created. Okay. So for now, what we do is we're gonna wait for a couple of seconds to get this complete. Okay. So once this is completed, which means that we have some data from the AWS Blue Data Catalog. Currently it is running. So what I'm going to do is I'm gonna keep the the recording for a seconds on pause, and let's come back. Okay, after waiting for more than 2 to 3 minutes, we see that the crawler is in stopping state. If I go to the database now and click on this database and refresh it, so here we should be able to see a table got created, this one. Okay, so now what we did is, if I go back to the diagram, so we have extracted the data from this S3 bucket, which is a raw data. Now it is converted into SQL and stored in AWS Data Catalog. Let's go and see from the Athena query. So if I go back to the data source again and then go back to the query editor, and here you're going to choose the data catalog, and in this one, if you refresh it here, so now you see that we have a database called S3DB, and then you can run a query on this one table by right click on this one. So you can do like this, click on these three dots, and then you see that preview table. And yeah, so once you click on a preview table, run again. So once you run again, you see that we are getting some data that is nothing but the data that is stored in this CSV file, which we stored this CSV file in the S3 bucket, right? That is, like say you see, if you see here, that is something like 10,001, 2, 3, up to 7. Yeah. So that data is now, being extractable, in the sense we are visualizing that data from the Athena query, right? Now, similarly, we need to do same thing from Amazon RDS to Amazon Athena, right? So once you have a two data sources available in the Amazon Athena query, then you can run a Amazon Athena Federated query. Let's see how to build a connection between the Amazon RDS to Amazon Athena, and then we can see that our data source will be available there. All right, so that is the next steps. Okay, so for that case, what we have to do is we need to go back to the Amazon Athena, and in the Amazon Athena, you see that there is an administrative privilege, administrative page, administration tab. Click on the data source and click on create a data source. In this one, you see that there are lots of data sources here. So here we're going to use a PostgreSQL, and then click on next. Once you click on next, so here you need to give your source data name. So here let me give it as a PostgreSQL. Yeah, so let me call it as a PostgreSQL DB, or say PostgreSQL data. All right, so this is our source name. Now here is the catch. Okay, so here the Amazon Athena data sources will use a Lambda connections, in the sense it elevates the Lambda to connect to the Amazon RDS, extract the data, and load it into the Amazon Athena data sources. Okay, so for that sake, we need to create a Lambda function here. So for that sake, you can just click on this one. So automatically by default, AWS takes you to a template that is in AWS Lambda. So underneath the AWS Lambda, you see that there is an option called applications. In the applications, we're going to create an application which is actually interfaces with the Amazon RDS to Amazon Athena, and basically it extracts the data from Amazon RDS, creates the data set into the Amazon Athena. From there it will elevate you to run the queries. Okay, so for that sake, we have to create an application configurations. So here in the application settings, you need to give the certain informations. Application name, so let it be like this. Okay, so let me call it as something like, yeah, something like this, application connector test. Yeah, so and the rest composite handlers, you can keep it default. Yeah, so okay, and then a composite handler, let it be like this. A secret prefix, you can give something like example secret prefix like this. So let me copy this here. So we'll call it as something like test. Yeah, and the spill bucket, so spill bucket is nothing but you need to give give the S3 bucket where this application can store its information temporarily. So for that sake, I'm going to give this table, give this S3 bucket here. Okay, so in the spill bucket, you give one example S3 bucket that is created in your account. Now next, in the JDBC connector configurations, so here we need to give the the database configurations here. So here if you see, right, so we need to give the default connection strings. Okay, so this default connection strings can be connected with using the the JDBC connection URL. So here I'm going to explain you how you need to construct that. Here you need to give the PostgreSQL because you're using the PostgreSQL as a data sources, right? So if you're using other versions, maybe the the JDBC connection URL might change for your information. Yeah. So here is JDBC PostgreSQL. Here is the database endpoint. So database endpoint will be available in the Amazon RDS. So if you go to the Amazon RDS and go to the, so this is my Amazon RDS, this is my instance, and I'm going into the connectivity and security. In this one, you see there is an endpoint. So this, with using this endpoint only, I'm able to connect from my PG admin client. Okay, for your information. So now we go back to the to the Lambda. All right. So here I'm gonna. So basically, we are constructing that JDBC connection string, right? So here I need to replace this, the database endpoint. So don't worry, I'm going to give this template, in the video's description. In the sense, you can find these files from my video's description link. Okay, so I have shared my GitHub link in the video's description. You can find it from there. Now, for now, I'm replacing with the endpoint, and then the rest is database. So if I go back to my PG admin client, so my database name is here. Is a test. So I'm going to give my database name as test here. Okay, so I'm going to give it as test. And after that, you need to give the username and password. So my username and password of my RDS instance is something like this. If I go to the configuration, so this is my username, that is Postgres, and my password is my super secret password. In the sense, these are all the credentials which you will be aware of your instance when you create it. Okay, so for now I have stored these information in my laptop, so I'm just copying it from there. And then finally I have constructed this JDBC connection URL, something like this. I'm going to copy that and go back to the Lambda, and here you need to paste it. Okay, and the rest all options you can keep it default. Disable spell. Lambda function names, you give it like a demo federated query Lambda. Yeah, so let me give this name, something like this. Yeah. Okay, so rest all option is default. Permission boundary is default. Security group, so here we need to give the security group name as it is been there in the RDS. So this is our security group, so I'm going to copy this default security group. So as I said, in this default security group, make sure that you have inbound access on port number, PostgreSQL port number. Yeah, that is nothing but 5432 has to be allowed. Okay, I go to the Lambda here, and then we're going to give the security group ID like this in the subnet. So I'm going to use the first subnet. Okay, so why we need to give this? Because by default this applications gets created, in the sense this Lambda will be integrated in that VPC. Yeah. All right, so I'm going to keep it this information, and I'm going to check mark this, that is I'm going to acknowledge this configurations, and then you click on deploy. Okay, so once you click on a deploy, basically what happens is it gonna create an AWS Lambda application which will be used in the Athena data source. Okay, so for now it is looks to be good because it has went into the application creation mode, and down the line you should be able to see the the information. Okay, so if you go to the deployments, in the deployment you see that there is a status called basically it will gonna show you here that is a rollback complete, in the sense it actually takes certain amount of time and the status will go in a deployment success. Okay, so once that is being done, I'm going to come back, and then from there we're going to start it again. So for now it's going to take some time, right? So for till that I'm going to go on a pause mode. Okay, so after waiting some time and doing the troubleshooting, so basically it will go in this state, that is it should go in a create complete mode, which means that it has deployed the the required Lambda, right? So now if you go to your AWS Lambda and go to the functions, in the functions you should be able to see a function called PostgreSQL Lambda, right? So basically, so this is, you see that enables the Amazon Athena to communicate with the PostgreSQL. So in the sense, in an AWS account in a region, you will be allowed to create only one Lambda like this. Yeah. So for that sake, this is the lambda, which got created. Now what we do is we need to click on that and copy the function arn. So like this, okay. So I'm going to copy this function arn and go back to the data source connections. Okay, so we were where? So we were on the Amazon Athena, and we're creating the data sources. In that one, we provided this this data source name. We were creating the the create lambda function, right? So now we got created the lambda. So now you need to give this ARN. Remember, you need to give this ARN. So click on that lambda ARN, yeah, and then click on next. All right. So with that default option, click on create data source. If everything is good, it will say that the data source PostgreSQL data was created successfully. So this is the information you need to get it properly, right? So right. So if you click on this, and if you're gonna explode automatically, in the sense, if the connection is proper, you will see that green banner plus associated databases. You see that automatically it has identified the associated the database schema, right? So public is our schema. Underneath that, employees is also a table, right? So it basically automatically identified, and it is actually able to identify the columns as well. Okay, so with that option, so basically if I go back to the diagram, so here we also established connection from Amazon RDS to Amazon Athena. Now we have a two data sets. Now let's see how we can run the Athena Federated query. So here we go back to the query editor again, and then so then we're gonna close this query. We're gonna close this as well. So let it be this. We need that, yeah. So I'm gonna close the other query as well. Now first let's see data set sources. Okay, for now we have AWS Data Catalog, which I have shown you. Underneath that we have a database called this. Underneath this database we have a table called like this. If I click on this the table and do a table preview, and it is actually listing the data which is extracted from the S3 bucket. Now we gonna go back to the another data source, that is Postgres data, which we created just now, right? And it is actually listing the database, which is nothing but schema here. So we're gonna choose a schema called public, because that's where we kept our employee table. And here you go, right? So our employee table is now listed. And then click on this click on this three dots of the table, and click on a preview table. So once you now click on a preview table, it should be able to give you the data. That is, if I go back to my PC admin and where I'm running the query called select employees, it should be able to give the same data here, right? So here you go, right? So we have a column called ID, name, city, email, destination, blah blah, and finally it is appending few columns which you can ignore. So basically, in the sense, the data that is needed from raw and the data that is needed from Amazon RDS now available on the Amazon Athena, and that's where we're gonna run a federated query. Now let me go back to the the federated query, which I'm going to show you, right? So here we can elevate the the SQL, or basically T-SQL queries, and construct a query in such a way that it will join the tables created from the two data sets, two data sources, one created in the AWS Data Catalog, one created by the RDS connections. Okay, so for that sake, what we do is we're gonna construct the query here, like with using the SQL join. So we will say select a star from the public, from the employees. Okay, so our employee table is coming from here. So we have a select star from this. So that's what the query is telling. And the join left, in the sense, employee table has to be joined with the data catalog table. Okay, so our data catalog table is something like this. So I'm going to copy this table, yeah, and then we're going to replace this query here. So we are saying that hey, join the public employee table with the data catalog S3 table on where, on this particular columns of the both the table. Okay, so for that sake, the public employee table, so if I go to the public employee table, so public employee table has a key called ID, column called ID, and then the S3 bucket table has a key called, or column called, industry ID. So we can elevate these two columns on join. So that is what I'm doing it here now. So that is a join on public employees on AWS Data Catalog on this one. Okay, so for that sake, I'm going to copy this this query like this, yeah, and then yeah, so then let me replace this this with the this with the this Okay, so we're going to replace it with this. All right, so basically I'm going to give the refresh. So basically what we are doing is we are actually merging the table employee with the table that is created out of the S3 crawling. Okay, now with this, basically we are just running a very simple join query, which is nothing but actually joining the two data source and giving us the required insight, nothing but that is a federated query. Okay, so that is what federated query means. If I run this the query, we should be able to see a collective insights on the both the types of data set. Okay, so here you go, right? So we are actually merging two types of data set, that is from the, so this is whatever you see at the Gmail, so this is coming from Amazon RDS, and the other one that is which is now with the name like industry ID, that is basically coming from the raw data, right? So now you see that how important it is, so how great insight that you can get it when you can try to club the multiple types of data on Amazon Athena and then run the required queries on this data, right? So that is actually the extensive step, okay, to get the insight on the different types of data. All right, so with that note, I have shown you the things need to be shown here. So here we have seen that we have two types of data that is stored in a Amazon S3 bucket that contains the raw data, Amazon RDS, which is actually contains the structured data, that is SQL data. Now we extracted these two data and came on Amazon Athena, and from the Amazon Athena we run an SQL query that is actually called as Amazon Athena Federated query, which will give you extensive business insights on your enterprise data. All right, so with that note, I have shown you the things need to be shown in this video. Finally, a kind request, please do subscribe my channel, that would really encourage me a lot. With that note, thank you, thanks a lot, and see you in the next video.